Alright, let's take a look at this problem here. They're asking us to evaluate the cotangent, the inverse of cotangent of negative radical 3 over 3. Alright, so a couple of things that we can do here. The first thing is, it's an expression, I don't know, it helps me, I don't know why, but I like putting this equal to an equation. So you can just pick your favorite whatever. So my favorite one is x. And then what I'm going to do here is I'm actually going to take the inverse. So I'm going to switch these. And when I switch these, I now get cotangent of x equals negative radical 3 over 3. Remember, when you do the switch, this is like an on and off switch. Because I did a switch, I have to now take it off. I have to figure out where cotangent of x is negative. Class, where all students go? Now this acronym tells you where the trig functions are positive, but I want cotangent to be negative. So I'm going to find where it's positive. So it's positive here and positive here. That means cotangent will be negative in quadrants 2 and 4. So we're going to eliminate those two quadrants, right? Okay, so now that I think about it, I'm not quite sure where negative radical 3 over 3 is not on my unit circle. So I have to do something to it. What did you guys do? There's a couple of ways you can do this problem. Anyone? Okay, you could rationalize. Here's what I did. I'm just using something we already know. What do we know about cotangent? 1 over tangent. Let's see if this does anything. Okay, still not helpful because this is not on the unit circle, right? Okay, so all I'm doing is I'm taking the reciprocal of both sides. The reason why I'm doing that so I can get this side to be tangent. You see that? But now, what do you have here? You have now the radical in the denominator, and here I can now rationalize. Let's see what happens now. So I have tangent of x equals negative. This becomes what? 3 times radical 3 all over what? 3. Is there anything we can simplify? Tangent of x equals... Okay, how do you make this radical a fraction? You see that? Now we're getting somewhere, because usually in the unit circle you just have 1s, 2s, and radical 3s, and radical 2s. Does that make sense? So now I'm getting at least some kind of numbers that I kind of want. Okay, what do you know about tangent? Someone said opposite of the adjacent. Okay, not helpful for the unit circle. What else? Okay, we already did that, right? So I'm not going to use a reciprocal identity. Y over x. And let me now prelude to what we're going to learn in chapter 5 with trig IDs. You really, the y values, is that the cosine or sine? It's the sine values, and then cosine is x's. So they call that the quotient identity. Tangent is equal to sine over cosine, but I could just use y over x. So now I'm going to pull out my paper plate. Remember, we have 2 locations to look for. We're looking in quadrants 2 and 4. So I'm going to write down x is equal to. And I'm looking for a x value that's 1 and a y value that's negative radical 3. X value that's 1, see a 1, and I see a y value of radical 3. Now you might say, Mr. Ng, you just told me the negative radical 3. But remember, this negative sign, I kind of drew it poorly, is in the middle. Both the expressions, negative radical 3 over 1 or radical 3 over negative 1, still gives you a negative expression, right? Negative divided by a positive equals a negative, or positive divided by a negative is negative. So why do I say that? Because right here I have 1 over radical 3. So that would give me a tangent of radical 3 over a negative 1. So I'm going to write down 2 pi over 3. Raise your hand if you got that one. Okay. And then now I'm going to look here in quadrant 4. Same thing. Where is it, class? Oh, look at that wonderful thing about the unit circle and us using our paper plates. Look. Green. 1 and radical 3.